All right, we are on section 7.1D. We're going to simplify square roots today. All right, so in the previous lesson, we talked about square roots. So we're going to talk about those square roots that don't end up with perfect squares underneath the radical sign. So let's look at some examples. These are square roots that do not always have whole numbers as an answer. So let's just look at these and I'm going to point out a couple things about these. So if you look under the square root symbol, and if you look at all of these, you're going to see that all of these have a number in front of the square root. Let me write that better. They all have a number in front of the square root sign. That's the first thing we need to do. You can just jot these down on your notes. They all have a number in front. Another thing they have in common is the numbers inside are not perfect squares. Also, the numbers inside are smaller than the original number. If you look too, the number inside is a factor of the original. 2 is a factor of 8, 2 is a factor of 18, 2 is a factor of 32, and 10 is a factor of 40. So here's another thing. The number inside is a factor of the original. And one more thing that I can point out, or any other things that you recognize, you can just let me know. But that's all we're going to talk about for now. Let's go on. So there are two strategies to find or simplifying a square root. You can use the one that works better for you. Some of you are visual, some of you not. So you can use whatever works better for you. So the first strategy is to find the greatest perfect square that's a factor of the number inside the square. So I'm looking at 8, and I know that 4 times 2 is 8. 4 is a perfect square. So 4 is 2 times 2. When you have a perfect square, you're going to pull one of those out. So 2 times 2 is 4. I'm going to pull one of those 2's to the inside, and then you're left with the 2. Okay, so let's try another one. Let's try the square root of 40. So in thinking about square roots or factors of 40, I know that 4 times 10 is 40. And then the square root of 4 is a perfect square. So 2 times 2 is 4. I'm going to take one of those 2's, pull it to the outside. Since this isn't a perfect square, I'm going to leave it inside, and that's simplified. Let's try another. Be patient with yourself here. 32. I'm thinking about the factors of 32, and I'm looking for perfect square factors. I can think of 16. You want the greatest perfect square factor that you can find, times 2. 16 has a perfect square root of 4 because 4 times 4 is 16. So I'm going to pull one of those 4's to the outside, and then leave my 2 on the inside because that's not a perfect square factor. You try 45. Think of the greatest perfect square factor, the greatest factor of 45 that is a perfect square. Give yourself a minute. I use 9 and 5. So that's the square root of 9 times the square root of 5. This is a perfect square because 3 times 3 is 9. So I'm going to pull one of the 3's outside and leave that square of 5 on the outside. All right. So we're going to go back and do all of these over with a factor tree method. This is the way I started doing these, but then I moved to the other strategy. So let's start by making a factor tree of 8. So we used 2 times 4, the square root of 2 times the square root of 4. We kept going because there are more factors of 4. That's 2 times 2, so you have the square root of 2 and the square root of 2. So for every pair you circle, you pull one to the outside, and then if you have one left on its own, it stays on the inside. If you are pulling out more than one factor, you multiply them by themselves. Let's look at the square root of 40. So I'm going to make a factor tree. So I have the square root of 4 times the square root of 10, and then 4 breaks down further into the square root of 2 times the square root of 2. So you can't go any further here. Well, I guess you can, because you're going to have the square root of 5 times the square root of 2. All right, so I have one pair. I'm going to pull out 1 for every pair. So there's a pair of 2s. I'm going to pull that to the outside without the square root sign. Inside, I don't have another pair, so I have to multiply those back together to be square root of 10. Okay, let's try making a tree for the square root of 32. We can go, let's go a little different way. If I go the square root of 8 times the square root of 4, the square root of 4 can become the square root of 2 times the square root of 2, right? This can become the square root of 4 times the square root of 2. I can still go further with the 4. 4 becomes the square root of 2 times the square root of 2. So here's the benefit of the trees. You don't really have to start with the biggest factor, because if you follow the tree down, it will get you to go where you need to. So I have a pair of 2s, and then I have the single 2 left. So I have 2 pairs of 2, so you multiply them together. 2 times 2, 1 for each pair, is 4, and then that single 2 is left inside. Okay, I'm going to make myself some room here so I can do another one for you. I'm going to erase that. And we're going to do 45. So the square root of 45, if I make the tree, breaks down into the square root of 9 times the square root of 5. I can break down that 9 further into the square root of 3 times the square root of 3. Can't go any farther with the square root of 5, but I have a pair of 3's here. Remember, I'm pulling one to the outside for every pair without the square root sign, leaving what's left over inside. So whatever method you would like to use, that is up to you. All right, let's see if I can actually make the page go. All right, so let's try some. So let's try 50. So I'm going to do the tree method. I'm going to break that in down to the square root of 25 times the square root of 2. Break this one further into the square root of 5 times the square root of 5. This is by itself. This is a pair. So I have 5 root 2 as my answer. These ones that are fractions look scary, but all this is the square root, the square root of 1 over the square root of 4. So the square root of 1 is 1, the square root of 4 is 2, so my answer is a half. The square root of 200 becomes the square root of 100 times the square root of 2. I'm going to break this further into the square root of 50 times the square root of 2. And this I'm going to break down square root of 25 times the square root of 2. This goes 5, the square root of 5 times the square root of 5. Trees take up a little more room. So I have a pair of 2's and a pair of 5's. So I'm going to pull one for each of these. I have a 5 and a 2. 5 times 2 is 10 on the outside. This stays inside. So 10 root 2. This next one, I'm going to take the square root of 4 over the square root of 25. Square root of 4 is 2. Square root of 25 is 5. Those fractions are easier than they look. 72. Let's try the other method here. I'm going to think of all of the factors, and the highest square root factor, perfect square factor I can think of is 9 times 8, which is the square root of 9 times the square root of 8. So 8 now has its own perfect square factors. So I have 9 times 4 times 2. Square root of 9 is 3, square root of 4 is 2, and the other 2 stays inside. So I have 6 root 2. I'm going to take here the square root of 49 over the square root of 36. Those are both perfect squares. Square root of 49 is 7. Square root of 36 is 6. All right, so I'm going to do the tree here. Let me erase some of this noise here. So I'm going to take the square root of 21 times the square root of 7. And then I'm going to break this square root of 21 down into the square root of 7 times the square root of 3. I have a pair here. I'm going to pull 1 7 to the outside. The square root of 3 stays inside. Let's square that up. Okay, the next one is interesting. So this has a negative sign on the outside. So you're going to have to take whatever your square root is on the inside and tack that negative sign back on. So the square root of 36 is 6, and we're going to stick that negative sign right back onto the 6. So here I'm going to do the tree. I'm going to do the square root of 32 times the square root of 4. Break that down even further. Into the square root of 2 times the square root of 2. 32, I'm going to do the square root of 8 times the square root of 4. Hopefully I can fit this. This becomes the square root of 4 times the square root of 2. And this becomes the square root of 2 times the square root of 2. And I have to break this one down, which it's not going to let me. So I'm going to move up here. This is my last level. Let me just stop, and I'm going to continue on another section of video. So see part 2 for the square root of 128.